Let's talk about standard conditions of measuring enthalpy changes. Various experiments have shown that heat changes are affected by physical factors such as temperature, pressure, and concentration. Due to this reason, it is necessary to compare enthalpy changes for different processes at the stated conditions. One condition is that the temperature is 25 degrees Celsius, that is 298 Kelvin, and a pressure of 1 atmosphere. Or 760 millimeter mercury. These two conditions are referred to as the standard conditions. Therefore, enthalpy change at conditions is referred to as standard enthalpy change. Standard enthalpy changes. And normally denoted as that is the standard enthalpy change, where the theta you are seeing are written as a superscript is what denotes the standard. Example: when ethanol is burnt at negative 25 degrees Celsius and a pressure of 1 atmosphere, then the heat change that occurs is standard and will be, that is for combustion, and will be denoted as delta H, standard for combustion. If you want to go specific, you put ethanol in bracket. When writing chemical equations for reactions which are accompanied by heat change, then the amount of heat evolved in the reaction is also included. Then such reaction is what we have been calling thermochemical equation. And when writing this thermochemical equation, you can include the standard when writing delta H. For example, 1 mole of ethanol burns at standard conditions to produce carbon 4 oxide and water. At the same time, there is production of 1370 kilojoule of heat. The thermochemical equation for this reaction will be written as follows. CH3 CH2 OH oxygen to form 2 moles of carbon 4 oxide gas and 3 moles of water. Delta H standard for combustion is equals to negative 1370 kilojoule per mole. That is the thermochemical equation. Now, from the above thermochemical equation, heat is evolved when ethanol is burned in oxygen gas. So this change is referred to as exothermic reaction. There is a release of heat which can be represented in an energy level diagram as shown below. So let's have our energy level diagram. Is y-axis, x-axis, so that is for the reactants. Activation energy included, so we'll have that as the product. So we call this activation energy. Delta H standard combustion is equals to negative 1370 kilojoule per mole. So this is 1 mole of ethanol undergoing combustion to form 2 moles of carbon 4 oxide and 3 moles of water. This is what you call reaction path. And this is energy, or simply enthalpy in kilojoule. That is what you call the illustration of the above thermochemical equation in an energy level diagram. You can see there is an inclusion of the standard condition. That is all about standard conditions of measuring enthalpy changes.